Today we discuss about Java IO packages, which we call input and output packages. So whenever you are writing a Java program, if you want to access any data from the file system, or if you want to write data back to any file system, you need to use the Java input and output packages, which is called java.io package. Suppose you want to read the input of the keyboard. You want to write the data to any external systems, which can be a file, which can be in a Word document, which can be in a PDF document, or which can be an writing to any other computer, connecting to another computer. We will use Java input and output packages. So some of the real-time example is when you are sending a photo or a video in the WhatsApp message, you just paste you take the photo from your WhatsApp, you forward it. Or in your Gmail or your email, you set the file attachment and you send the file to someone else. Or if someone has sent a file to you, you download the file in your computer. So in order to accomplish that, generally we will use the Java input and output packages on a very high level. So using a Java, how we can write the file. The main class in the java.io is the file object. If you see that file f is equal to new file, you create a file object. So in my computer C work folder, there is a test file.txt. Test file.txt has been represented as an object called f. So far we have been reading it, writing an objects, writing a class. From there you create an object. Here we are creating an object of this file by representing an f. With the f, now you can manipulate this file. You can, if you're using the f, you can type f.getName, you get the name of the file. If you're using a path, f.getPath, you get this C workforce, C :/ work, you get the path. And you get the absolute path, means that you get up to C to complete path, you get absolute path. And also, if you from there you can find the file metadata, like parent, who is the parent of this file. The parent of this file is a work. And is it exist? You can check that the file exists or not as well. So you can find out whether the file can be writable or it can be readable file, or it is a directory. So what is size in bytes? Size in bytes. So whatever you can do by selecting a in the Windows computer system, right click on a file, you get the properties. You can get all these properties by using a file object. The file object is a part of input and output file system. So create a one folder in your computer, a C:work, and create a file called test file.txt, and write something into the text file, some kind of a junk character, or write something whatever you like, and execute this program in your computer. You understand that how the data is coming from this file system. So can we just take a look at it? I will share this file, then or you can write it directly from this file system. You can write it from here and you can develop this code in your computer. So let me share this file to you. I have shared the text file. So type exactly like this, or you can take the files and copy to your training folder and create a file create a folder called C, comma, colon, work, and create a file called test file.txt and run in your local computer. Then you will, as soon as you run the command, you will get this output. So let me run this program for you. Java C, text file.java, text file. You see that I did executed this file. The file name is test file.txt. Path is, it has mentioned the complete path. And I do see that absolute path. And parent is the work folder is a parent. Is exist, the file exists, it is saves that. Is writable? Yes, it is writable. Is readable too? Is a directory? Means it is not a directory, it is a file. File size in bytes. What is the size of this file in bytes? So we get this 29. So if you see that here, path and absolute path almost showing the same kind of an information to you. So you can use the path or you can use the absolute path. Almost same kind of behavior you will get it. Some of the cases, absolute path is represents the complete path which is doing it. Path represents the C/work, and up to that, sometimes it will show that. But right now, Windows it is showing. But maybe if you go to the Linux environment, it may work in different direction. Windows it is working like this. This is how we use the file object. So generally, whenever you want to load a data from the file system into a Java program, you can write using a file object, you can manipulate the file. The scenarios are like this. The main kind of scenarios you get it is, suppose there is a one computer system and one more computer system is located in a different country. They want to send us some data from one computer system to another computer system. Whenever they want to send it, they create a files in a CSV file or text file, and they will push the files to one computer system to another computer system. Whenever they push these files, we need to read these files and load the data into our databases. One way is that since you are using a Gmail, generally you write a message to your friends by sending an email. Some of the cases you can still send an attachment to your friends. So attachment also a message you are sending to your friends or your family members. Like the way in the financial sector, mainly I have seen in the trading platform, currency trading. What it does is a country it does the trading of a particular currency. It's taken America, US. Well, US has a lot of financial banks. In India also, we have a lot of financial banks. In the banks, generally, you go and give a currency. I want to convert from rupees to dollars, or in US, you want to convert from dollars to rupees. So if we do this currency conversion, then afterwards we need to report back to the government agencies of Indian government as well as US government, saying that as a country whole, how much currency we have traded it. We need to tell this uh, data every day to the government agencies, so that based on that, the supply demand of your currency will increase or decrease. The dollar rate when comparing with rupee will increase and decrease. Whenever we do this kind of a mechanism, so the banks will let the government agencies know that we have a traded money of so and so $1 million today. Those data, they will create a file and they share the file to the government regulatory agencies. The regulatory agencies, we need to read this file every day and understand, so that that will help you to maintain the cost of the currency conversion rate every day. This is the one of the example. There are many examples we use and deal with the files and day-to-day life in the day-to-day life in your applications. The second concept in the file input or output stream is, so input stream and buffer input stream and data input stream. What is the input stream? Input stream means you are reading a data into a system. This read as a bytes. Your file you written in English or you written in your own language, but a computer always considered as a bytes. So input stream means streaming the data from an input, any one of the input. There could be file system is input, or you can input as your mouse data or your keyboard data also an input. Anything is called input. So example is that you have a pipe and you take the water from your well and water in the plants. Means that, so there is a well, so you put a pipe inside and you run the water, and the water is coming from your pipe and you are pushing into the plants. So input is here is input, the data is coming from well. The stream is the pipe is stream, which is getting the data from the water. And what is output? The plants, you're pushing the data to the plants finally. So input is well, output is consumed by plant. In between, the pipe is doing a mechanism, taking the water and planting the water in the plants. So as a simple example, I'm trying to correlate with the day-to-day real life. Buffered input stream is like input stream, but what it does is, assuming that before we planting to the water, we create a small tank, and the tank holds some data, some water before you before you water into the plants. The advantage of buffer means the water which is coming from your well, you're not supplying directly to the plants. You are creating a small tank. Maybe within a tank, you can do some manipulation. Maybe you can add some chemicals to the water, or you can purify the water before we giving to the plants. That's an example I'm giving it. Generally, the buffered input stream will help you is, you read a data from a file. Before you sending the data to some other system, you can manipulate the data. You can enrich the data, then you can send it to your downstream system. So in this case, using the pipe, you pump the water from the well and sending to the small storage area tank. And after the storage, water is staying in storage tank, not going to the plant in the water. Maybe you can filter the water, or you can add some chemicals which is good for the water, or maybe from this water you can split into two streams. Again, from the tank you can create two more walls. One goes to planting, one which goes to your pot, fill up the pot also. Then you can split this water from this tank also. You can do manipulation here. The buffered input stream is also input stream. It is reading a data from the input source, but you are able to control the data, what you have read in the byte streams, and send it to the water in the plants. That is the difference between buffer input stream and input stream. Data input stream is also like a input stream. What it does is, it converts the data into data mechanism. Generally, if you open a file, you will have English words and you have numbers mostly in the file system. So it converts into data types, primitive data types. It will understand that it understands the data, whatever you is the written in the file, into a string or int. It does the conversion. You can manipulate the data based on that. If you see in this diagram, so this is a disk file on your file system. The file input stream is reading as a bytes, and buffered is block of bytes, means that you can creating a block of bytes. You are reading as a bytes, it is blocking block of bytes, means that you can make it like big chunk, and then you can write Java program can read like that way. Other example, if you see here the diagram, pictorial diagram, which I'm trying to explain here, you are reading from the disk file input stream, because file, why you are reading file input stream means we are dealing with the files. You use the file input stream. And then you went into buffer input stream, input into buffer, and you converted block of bytes, and you send the data to data input stream, which means that it converts the bytes into a data into double, or it can convert into a string also. Then it supplies Java program. It means that whatever is there in the file here, and the file can contain your written name, your age, your salary, your date of birth, everything has written in the file. So the Java program can directly convert that data into an actual name, like name. You can understand the name, and it can understand it is a date of birth. It can understand it is your salary. It can convert like that way, Java by using the data input stream. Why we need to do like this? Whenever you read a file, you need to understand what content of this file through programmatically. Then only you can take a certain action on this. That is where you help. It helps using a data input stream. Similar way, input stream, there is an opposite is output stream. Means that you take the water from the well. Means if you take a pipe, assuming that if you take a pipe, so one edge water is going inside into the pipe, other edge water is coming outside of the pipe and going to the plants. So here output stream is that the exit of the pipe is the output stream. The entry point of your pipe, the water entry into a pipe is input stream. The water exit from your pipe is the output stream. So almost same, the pipe is your stream. So output stream is exactly like an input stream. Only thing is that it is pushing the data outside of the stream into wherever the target system, wherever the target it is. Maybe you can read a file and you can write it to different file. So input is file, output also file actually. And your streams are reading from the file and writing to the another file. Why do you want to write to another file? In between, a Java program converts the data however you like to. That is the helps of these streams. Like the way input output stream, we have a output stream means writing a data. So as I mentioned in the input stream, we are talking about for reading. Here we are talking about writing a data into the system. And this write as a bytes. The example is same. Using a pipe, pumping the water to the wall and watering the plants. Means that you are pushing data out from the pipe and going into the water. Destination the water. Buffer and output stream also same like a buffer input stream, but it is holds some data before we write it to the file system. Data input stream also same like that. It will convert into write in a data. If you see in this diagram, so you have developed a Java code and we have a data source. And in this data source, and data source can be a file or it can be a keyboard. It can be file or it can be keyboard. So you read a data from the data source and Java program will read the data and finally it write into the destination. Destination can be file or it can be a new hard disk or it can be anything else. You can decide based on your needs of this. So Java program that reads a data from the input stream and write the data to the output stream. As soon as you write to the output stream will connect to a file, or you can connect your output stream to a hard disk, or you can connect your output stream to a monitor also. Monitor of your computer system is also an output stream. Keyboard is also an input string for your program. So you might have read in a computer, what is the input devices of the computer? What is the output devices of the computer? Input is mouse and keyboard are the input devices of your computer. Output devices is your monitor and your printer, also an output device. So you can read a file from input device and using a Java program, you can directly send to a printer where it can print the file. You are doing that most of the cases. You might have printed a lot of files in your home to send the data to the printer, so the printer does the printing. You might have noticed that whenever you do a print, and it takes a couple of seconds to print the paper. The reason it takes a couple of seconds is that file will be transferred from the computer system to a printer. Printer also have a memory. It will store all of your file content. Then after the data has been received from your computer system to the printer memory, printer also have some kind of a CPU and it also has some memory. It stores your file and then afterwards it will issue in a printer command. It prints physically so that you get the data in your printer. Whenever you want to do this kind of a programming, we need to implement a input and output streams. Generally, you get a water bills, you get a electricity bills, you store in your computer, and you click a print on your computer. That will prints on the paper. So in the Windows, they might have written this kind of a streams already, and they are doing this kind of work for you all. Because printer is in a different device, so these kind of input and output mechanism, they within a printer they might have written already for you, so that you just click a button. It simplified your task. Suppose you are the Java, you are the programmer, you want to develop such kind of printer technology, then you need to write a code. If you go to the grocery store, you see that small Zebra printers. Like, it is not a big printer. You get your bill. You go to a restaurant, you get a small bill. Those are the different kind of printers. They within the printer within the printer itself, they've written output streams. So they get a file, they get a PDF, they get any kind of a document you can able to print it. Whenever you want to do that kind of functionality, we need to understand how these streams will work, and then only you can write a program like this. And the real examples. I will stop for any questions from anyone. Please let me know if you understand these concepts. So let's get into the next one. So this is creating a file. This is one more example I want you to understand. So I'm creating a file here from your input keyboard. So here, what I have done is I created a data input stream. Data input stream, I created an object, is equal to new data input stream. And I'm taking system.in. Means system.in is my keyboard input. You might have written system.out.println hundreds of times so far. System.out. System is a Java class. .out means that you are putting a data to console. Those are also either output streams. You written system.out.println means you are telling system out, pushing out. .println, printer means print on the console. Ln means next line. Whenever you print, it will be ln. You can put system.out.print also. If you put system.out.print, it will print on the same line, whatever the statement. If you use ln, print ln, it will print new line. New line. Ln means new line. So here, the similar way, you are taking system.in means whatever you are typing, I'm reading it by data input stream. Then I created one more file object, dummy file.txt. I created dummy file.txt. So this is the independent. So I created a buffered output stream. Buffer output stream, I'm telling that I'm giving a file input stream object. It means that I'm just initializing all these things. The data which is coming to the buffer input stream, buffer the data. How much you need to buffer? 2048. Means I told you, when you take the water from the water tank, I create a small tank and I hold the date, I hold the water for some period, then I water the plants. Means the tank I created. In the real programming, buffer input stream, I'm creating a tank of 2048 bytes. Means that much of tank I'm holding it. I can increase this one to 1 gigabyte of tank or 500 mg of memory. I'm assigning this buffer the tank size dynamically before writing to the file system. So I'm telling you the output stream means send it to the output. Which output I want to send it? File output. This file output sending to the dummy file.txt. This is kind of a plant, assuming that this is a kind of a plant, so watering into the plant. And this is a tank, buffering everything. How much tank size? 2048. And I put like, enter, I'm send this some kind of a text message I mentioned. I'll explain this one actually. Then what I did is, here is the while loop. In the while loop, character, data input stream dot read. I'm reading everything, whatever it is coming from here. As soon as I read the data and I am writing, write. Output stream always use a word called write. Input stream always use a word called read. I'm writing this into a characters. Whatever I'm getting, I'm reading as a characters. These characters are going to store in this buffer input stream. So I'm using the object of buffer input stream dot write. I'm writing to this buffer input stream. These characters. These characters keep on I'm writing it, and this one will push us to the file output stream. Finally, it will store in the dummy file.txt. And I'm holding some kind of a buffered, like tank where I can hold some data for some period. And after the work is completed, I'm closing the stream. Buffered in output stream, I'm closing it. As soon as it closes, the data will be goes inside into the dummy file. So this is a very interesting concept you need to understand, the linking between all these things. Input stream means I'm taking input from system.in. System.in is my keyboard input. Whatever I type in keyboard will come. And this is clear, input stream I'm clear. And I'm output also I'm deciding. So input is coming from keyboard, output is going to dummy file. So in my example here, input is a keyboard and output I'm sending to a file. So I have defined the input first. The data, read it from the keyboard. I define the output now. Data, send it to the file system. That is the meaning of this data input stream. Reading from a keyboard and sending to the file. I define input and output now. Now I'm linking between these two things. How I am linking here? Through a buffered output stream. Buffer output stream means even if you don't write buffer output stream, it will work. The program will work. The advantage of buffer output stream is it will help you to, because reading is happening very fast and you can't write it in the same amount. The water is coming from a well so fast, you need to consume the water equally to watering to the plant. If you don't consume the water into the plant, the pipe cannot read the water anymore. Like the way in your home, you want to get a fresh air, you need to open the windows. From one door, you get the air. Another door, you need to open the windows to go out, then only the fresh air comes into your home. Otherwise, air will not come, even though you have fresh air outside. You should have in and you should have out. Then only the air will flow into your home. Similar way, when buffer input stream will help you to hold some data, then write into that. It won't time. So keep on writing here. Keep on writing means it is not writing to the dummy file. It is holding inside here all the data. Whenever it exists, it reaches the more than 2048, it means it crosses 2048, then it writes. One time it will write it, not every time it is writing. I'm typing from keyboard every time, doesn't mean that it is going writing to the dummy file every time. And keyboard, I'm typing, and buffered this much, 2048. If it exists, if it is limits crosses 2048, then I write one time to dummy file. Advantage of this doing like this, your performance will increase. The program will work very fast. So instead of writing every time, what I'm typing it here, every time you write, it takes a lot of time. So I'm writing only one time whenever it crosses the 2048 size. And I'm closing it off first also. So let me demonstrate this code. I have already shared this code to everyone, or you can take a look at it and type it in your computer also. I already shared it in the chart window. I can share it again if you want. Let me run this file to you. So I'm invoking a file, Java create file. Let me compile the file, Java C create file dot Java and Java create file. So I created this dummy file. Let me open the file also here. So since I have not mentioned the directory, it will always write on the current directory where I am executing. I am executing the code from here. It always execute from this file will be created here, dummy file. So let me open my code. What file I have created? Yeah, I created a UMS file.txt actually, not dummy. So let me open this file. So right now, this file it has a queue. So here, learning IO stream. Learning IO streams, I type it. So let me open this file again. Open the UMS file. Learning IO stream. So I type Kiran, Sonia, Ravi. I type all the names and also type them by name. So I type here. I need to refresh the file. I can open it. So my names are coming here. From my keyboard, whatever I'm typing here, still the program is running actually. When the program ends, if I enter the ampersand, this program will end. And if I type some junk characters, So again, refresh the file, again open the file, it is storing it. So whatever I'm typing it is storing inside the file system. And it will end whenever I enter the ampersand, this program will end. And again, if I open this file, dummy file, this file will be has stored this much of data. So as I mentioned here, the input stream, the keyboard is input going into the stream, which is the data input stream. In the Java program is reading through data input stream, and I created a buffer output stream, and I created a file output stream. File output stream I created because to write it to the file. This is what I have done here. Data input stream reading from the keyboard system.in, or I can suppose if I don't want to read from a keyboard, if I want to read it from another file system, I should have created a file input stream, new file input stream, and give that object here instead of keyboard. Means I'm reading from one file and writing to another file. We need to change the stream. Data input stream still will be there, but you need to have a file input stream. So I have not written file input stream. Here only I have written input stream is the data. You can write a file input stream, and you take that from the file, read it, and write it to another file. That is also possible. Like the way here, I'm reading a file. Whatever I have just typed it, I'm going to read that file also. So here I created a file, dummy file, the UMS file text, and using the reader of the file to read it from the java.util package, scan the file, and reading the next line. Each line I'm reading it. As soon as I read the line, and I convert that line as a data. I'm reading it. I keep a threads.sleep for some time. Then I am printing on the console, and I'm closing my reader. So this is opposite of the file creation. This is reading the file. So let me read the file. So Java read file. So I have already created the file. So it is reading it. I gave why it is delayed? Because I gave a delay of 5 seconds. So it is reading slowly. And it ended as soon as it did. So let me run the both together. So here I am reading, here I am creating a file, and here I am reading a file. So what will happen here? So let me type some, and let me read the file here. See that I'm typing here, and I'm reading also. So I'm doing the parallel together. See that I stopped here now. I have stopped it. I'm not typing it because it will keep on reading every 5 seconds. The file has reached to the end of the statement, so no more data is available. This system has been, this one has stopped. Again, I enter it. Again, it is reading from the beginning. One more time. It will go up to XYZ. If I type again more than this, it will be reading again. So I have this is the input stream. I'm writing to a file called dummy file. And here is the read file, which is reading the data. Assuming here this is one computer system, and and this is a different computer system sitting somewhere else. The in between the mediation is the file, whatever the file I'm sending it. This is how the streams will help. Means one computer system has created a file and send that file to someone, other computer system, and that other computer system load the file and read the data. You can share the file one computer system to another computer system by sending an email manually, or there is some other protocol called file protocols, which can transfer automatically the files from one computer system to another computer system. So I want you to practice these programs in your local computer by run the two things together. Whenever you want to stop this, you need to type ampersand, it will stop. This will stop as soon as the reach of the file, end of the file reaches here. I will share these two programs I have already shared in the chart window, or you can type these two things, then it will help you for understanding. I have already shared. Let me share one more time. Read file .java and so you need to understand here. In this, right now, what I did is I have attached a file from my computer system, and I have sent a button, and in your computer system, you received a file automatically. It means that this Zoom chart window has implemented a file read mechanism. Means from my computer system, I have selected a file, whatever file I can select. I can select the index file, okay, HTML file, and I send a button, and it reaches to your computer. And from there, you download it. Whenever you want to download it, you need to convert that file into a proper, meaningful what I have sent you. Whenever you click download, then it will convert that into use the file output stream right in your computer. That's how the file has been transferred, which has been developed already by Zoom chart window. So file input stream is I have used it to attach the file. At your side, you are downloading it, which is using the file output stream. I am using the file input stream. In order to accomplish this, a programmer of this chart who has built for Zoom has done this programming in such a way so that you are simply clicking the button as a user. You don't even know what's happening technically behind the scene. That's how the file input streams, file output streams will help you in the day-to-day life. This is one of the best real example. Whatever we learned today, how it has been implemented in the day-to-day life. We don't realize, generally we just attachment and download it, but really they are implemented code like this. I hope you have clear understanding about the streams and the data input stream, buffer input stream, data output stream, buffer output stream, file input stream, file output stream, and also file object, how you can work with the file, how to work with keyboard, system.in. So you might have learned this concept today, and this concept will help you when the need comes to implement such kind of programming or thinking process. Then, hey, in order to solve this functionality, I should use the streams. You should think in your brain like that so that you can write the program as needed. So one of the example I have developed in my real life is whenever generally we do a trading, so we buy stocks, me means not me as a person. A company does, everyone buys the stocks. Once the stocks has been purchased by a common man through a company called Fidelity or any other companies in the world, they take this data and suppose you purchase the Google stocks for, and someone has sold IBM stocks for. At the end of day, once you sell it, you need to get the money. Once you buy it, you need to give the money to the stock market, right? So these tradings happen end of day. We get a file from the system. How many stocks has been sold? How many stocks has been sold by all my customers? I get a file, and I take this file and I will process this file end of the day, and and automatically goes to the bank, take the money out from them. And if someone has sold it, deposit the money. If someone has purchased it, take the money from the bank, and then afterwards transfer the money from one customer to another customer. We need to do this kind of tasks in the day-to-day life as in the financial industry. That's the one task. Second task is that whenever you are trading hours, you see that stock market price going up and down of any stock, Google stock, IBM stock, any stock. It keep on fluctuating. It may go up, it may go down. If you see observe from 9:30 to 4:30 p.m. Whenever this stock trading is happening, we constantly send the data to the stock exchange. How many people are buying, how many people are selling, supply demand. We need to take this data constantly. We need to send it to the stock market exchange so that they will change the price of the stock. For that, we need to transfer the data continuously from one computer system to another computer system. So that's where we use these streams extensively to send the data one computer system to another computer system. They cannot talk to one computer system, another computer system. They talk with the files. Or they talk with a web services concept, but that's a different thing. If you want to transfer a large amount of data, 1 GB of file, the best mechanism is that creating a file and send the file to other computer system, they load the data. That's where the real scenarios comes into play in the day-to-day life. And this is the one more example which I've shared you how the streams will be helpful. So I'm ending today's session about the files. If any questions, you can feel free to ask.
Sir, excuse me.